Good evening. Hi, my name is Adam Buckner. I am one of the live trainers here at Unity Technologies, and we try to bring regular live sessions to you here either through our website or through Twitch directly, depending upon which way you're logged in. This is episode 3 on Hat Trick, the Fun Catch game. We've made 2 sections before. In the 2 previous episodes, we have laid out all of the basic game logic and put in some of the basic UI controls. I'm going to go ahead and snap these on. These are turned off. Our game over label and our restart button. So if we're looking at this, let's go ahead into scene view and sort of take a look at what we have in the scene view here. We're dealing with 2D today. So we've got our scene view set up into 2D mode, 2D view mode, and we are also using 2D mode as the preference for our editor, and I'll talk about that in a second. And so we're looking at our UI up here, which is on a canvas. I'll cover that in a second. And then we have way down here our game. And so this is our game down here. So going through the basic game objects that we have set up in the previous episodes, we have our main camera, which is looking at the scene. We have our hat object, and our hat object is split into 2 layers. We've got the hat back and the hat front. Whoop. And that's so that when we catch our balls, that they can fall between these 2 sprite objects. We have our sky, which is the generic background that we have there. And then we have a container holding 3 grass units. Let's go ahead and put that into sprite tool there. So we can see there are grass sprites. We have a destroyer game object, and this is an edge collider that is surrounding the scene. So if any object falls out of the scene, it gets into contact with that edge collider, and then the destroy on contact script goes ahead and takes it out of the game for us. We have a game controller object, which is what's controlling our game, controlling the balls that spawn from the ceiling, from the top of the game. And then we have our canvas, and the canvas is what is holding our UI using the new UGUI. So I need to caution people that we are using beta software today, and I'm using a beta version of 4.6. So there could be some changes. I mean, we've pretty much established the look and feel of the new GUI, which we're calling UGUI. But there may possibly be a problem tonight, which I hope not. And also, there may be some small changes, but this is generally the direction that we're going to be going with the GUI. One of the things that we could take a look at is the canvas. All UGUI items need to be inside a canvas, and you can have multiple canvases. This particular game only has 1. And due to the issues of pixel perfect and scaling for the camera, you can see that that object is much, much larger than the rest of our game, which is to be expected. Inside that canvas, we have our timer text object, which is going to keep track of the time left in our game. We have a score object, and so those are text fields that are updated from our code. We have a game over text that pops up when our game is over, and we have a restart button. And all of these were made during the first 2 chapters. And if you want to see those, they will be under the archive tab in the live training section of our website. And if you want to, we can talk about that a little bit more in Q&A. So what I'd like to do to our game, let's go ahead and take a look at it playing. So our game right now, let's go ahead and turn those back off again. We don't need those on. The game over text and the restart button are meant to be turned off when we start the game. And let's go ahead and hit play again. So we have, I'm going to pause this at the beginning. So we've got a timer that counts down up here. We have a score over here in the other corner. And balls drop from the ceiling, and we try to catch them in the hat. So relatively simple. A simple game. And then it lasts as long as we've set our timer. At this point, it's 10 seconds just for the purpose of today's tutorial because it's short and sweet. And then we get our game over text and then a restart button that automatically changes color when we hover over it and changes color when we click it. And that simply just reloads the game. So what we'd like to do today, what I'd like to do with you guys today is I'd like to add a splash screen at the beginning and a start button so we can start the game, because right now the game just starts when we hit the play button. It's not really aesthetic. And then some cleanups and some polish as well, because the hat starts to move from the very beginning of the game. And then towards the end, I'd like to create some hazards, because right now we just have balls to catch. But I would like to create some bombs that fall from the sky that look a lot like those bowling balls. And when you catch them, they take points away when they hit us. So we're going to take a look at some things, including particle systems and how particle systems work in the context of the 2D editor as well. So let's go ahead and just get started and jump in, and let's talk about adding that splash screen. So I'm going to swap to my desktop, and here I have some additional sprites. And in these sprites, we've got our splash, and then we also have some button presses that we can use, restart buttons. We're only going to be using the single straightforward button right now. There is sprite swap and some other ways that we can use the multiple images, but I'm not going to be looking at that today. So let's go ahead and take that folder, and we can simply drag and drop it into our scene. And now there's sprites additional. Wow, we already did that. Only one of them, please. So there's our sprites additional, and we can see that they come in automatically as sprite objects. And if we look at the artwork that's been imported, it's been imported as a sprite 2D object or UGUI. And the reason for this being imported as a 2D sprite rather than as a base texture is because of our settings. We're working on a 2D game. I'm going to revert this here. And so there are two things that I think are important. When we're working on a 2D game, is making sure that our scene view is in 2D mode, not in 3D mode, where we're looking at the world in 3D space, but we can lock it where we're looking at the XY plane, looking down along the Z axis. Some of the differences that you'll see is our gizmo, our perspective gizmo disappears, and we're locked to that plane. The other thing that we have set up is in our project settings under the editor is that we have our default behavior mode is set up for 2D. Let me just see if I can zoom in over there. Oops, come back here. So there's our default behavior mode, and that's set up for 2D. And so when we have our default behavior mode for 2D set up, one of the important things is new scenes come in with their scene set up in 2D mode, new cameras are created as orthographic cameras, and all of our artwork is brought in as 2D sprites. So now we have our artwork in, and we want to make that splash screen. So let's create a new image. So it's going to be automatically created under the canvas. So I don't have to put it there. I want to go up to the Create menu, and I want to create just simply a new image. And with that, we then drag our hat splash into the source image and drop. And because it's sized 100 by 100 is the default, it looks kind of small. There's a nice beautiful button here called Set Native, so we can quickly click that and it'll come back to that native size. And then we can go ahead and center that. And then if we look in our game view, there's one thing that's a little bit funny that's going on right now because the UI will automatically scale to the current camera. And if I move to my scene view, it's scaling actually the UI to my scene view camera. So I need to go back to my game view and just remind it what size that we're working on. And this is something that will probably change. I believe that this is really because we're dealing with beta software. And so we can see that if we just drop that in, we go and do that in game view. So if I create a new image, and then go ahead and drop that hat splash in, and then go ahead and set native size, and then set that to the center. And this is the anchor preset menu, which we talk about in episode 2. So we can click on that, and we can set our pivot, we can set our position and our anchor all at once by holding down the Shift and the Alt key and clicking on the center. So that's all we have to do to get our splash screen up and running. So let's add a start button, and that's pretty much generally the same thing. Let's name this splash as well. Let's name this splash screen. Now to make a button, create button, because it's going ahead and assembling this button out of a multiple group of different objects. So we've got our button object, including the image script and the button script, and also we have our label, which has button at the bottom. Again, we want to use an image. We could just go ahead and use button. We could change the label. We could change the color using this default graphic, the GUI sprite graphic that is default. But let's go ahead and use our start button from our new sprites, and then go ahead again and hit set native size, and that will go ahead and hit that set native size. And let's center it I'm going to hold down my Shift key for the pivot, my Alt key to set the position, and click center. And so that'll pop into the center. The two things I'm seeing here is that the button is a little bit transparent, and then I also have this word button written on top of it, which is kind of annoying. The button that is written on top is from the label. And if you're using simple artwork with no text already written into it, then you'd want that label there on top. In our case, it's written into our original artwork. If we look at the start idle, you can see that it's written into the artwork. So it's already built in. So we don't need the label, so we can come along and just simply delete it. And the other is that by default, the button is semi-transparent. So let's go ahead and crank up that alpha to be fully opaque. And so we can use this for fading also and animating if we want to by just changing the alpha channel. But let's go ahead and leave that fully opaque. And now let's move it into some nice position, down a little bit. How does that look? Somewhere in there, above the hat, below the trick. Why don't we try -100 and see how that works? Why not? I love big round numbers. So now we've got our hat trick splash, and we have our button placed on the screen. But we now need to script to the button. We now need to make this button do something, because right now it doesn't do anything at all. So let's go ahead and select our button. Let's go ahead and make this start button so we know what we're talking about. So there's start button. And what do we need to do this start button to do? We need to do three things. We need it to turn off the splash screen. We need it to turn off the button itself. And we also need it to start our spawning coroutine. And if you've seen the two episodes, episode 1 and episode 2, you'll see how we write our spawn coroutine. We'll look at that in a second. And we need to be able to start that coroutine when we use the start button rather than having it start automatically when we start our game. That's on the game controller. So let's go ahead and edit that game controller script. What we need is a new function. And I want to make this public because we need to call it from the button. So let's write public. Oops, how about if we spell it correctly? Public. Come on, indent, please. Public, thank you. Public. How many times can I say that? Public void. Public void start game. So what do we want it to do? We want it to start the game. So we're going to make a public void function to go ahead and start our game. Now let's save this. And let's come back to Unity. And if we look at our button, select the button. I'm going to remove the preview window down here. There is an event tab. And you can create other events and you can attach them to this game object. But in this particular case, all buttons come with a default on click. And there's a list of things that will happen when we click that button. And in this case, it's empty. So let's go ahead and create a new thing to happen, a new function to call when the button is clicked, when on click happens. And there is a space for a game object, and then we can call a function on that game object. Where is our function we've just written? It's on the game controller. So we grab the game controller and stick that in. And then if you click the function, you can see all of the components that are on that game object, including the game controller, and then you can see we can call start game. So now on click, when we click this button, we are calling that public function on game controller to start our game. We can send parameters, which we're not going to talk about, or I guess in this case it would be arguments into the parameter list. We'd be sending arguments here. And you can also do multiple things by adding multiple functions that you can call from the same click. So you can do multiple things from that same on click. But we're going to do one thing. We're going to call that public function on our game controller. Now, if we were to test this, nothing would happen because we're currently hooked up to an empty function. Let's save this and return to our scripting and actually put something into that function. So we've got our void start game here. What are we wanting to do? Remember, we want to turn off our splash screen. We want to turn off the start button, and we want to start our coroutine. So the first thing we're going to need is a reference to the splash screen and a reference to that start button. So let's go ahead and add those to the top. That'll be a public game object for our splash screen and a public game object for our start button. Ooh, bottone. That's our start bottone. No, just the start button is just good enough for us. And we'll write this in our declaration. So we now have made public variables that we can populate those references in our inspector. And then we can say splash screen, set active, false. So we're going to take that splash screen and we're going to deactivate it. Same with our start button. Take our start button. And we're going to set active false on that as well. So when we call that, that function, when we click the button, first thing we'll do is turn off the splash screen and turn off the start button. The next thing we want to do is start our coroutine, which is currently starting here in our start function. So let's go ahead and grab that, nip it out of the start function, and put it down here in our start game. So let's save this and let's return to Unity, because now we've set up our references and we've set up the functionality of our start game. We've got our splash screen and our start button, and then we've got our game controller, which doesn't have that visible. So let's go ahead and populate those with our splash screen and our start button. Now let's hit save. Let's hit play. And if everything goes well, yay, we can move the hat. Timer's counting down, which we need to fix, and then when we hit the start button, the game starts. Now this is imperfect because, as we can see, our counter starts at, in start and continues to count down, and our hat is movable. So let's go ahead and start cleaning that up. First thing we want to do is delay that timer from starting until we start the game. So let's go back to our script where we've got our timer. Our timer is calculated here in fixed update. And so we're going to need some way to trap it. So let's create a new Boolean flag. Let's make this private, because this is only going to be used internally. A private Boolean, on, off, true, false, called playing. Are we playing the game? And so in start, let's put it in the middle here, playing equals false. Flare. Playing equals flare. That will certainly not be very good. Let's learn how to spell first of all. Okay, playing equals false right there. So we've now set our playing to false. So we start we start with not playing, and then let's take our fixed update and grab all of this and indent it so that we can surround it with if playing. So now we've trapped the code in the fixed update, so it'll only recalculate our time left if we are playing. And so logically, we start our game. We start our coroutine of spawn. We wait our 2 seconds for the game to get started and the players to get their hands on the controls, and then playing equals true. So let's come back to Unity and go ahead and hit play. Good morning. So we're recompiling there. And now we can see that our timer's not counting, score is 0, nothing's falling from the ceiling until we hit the start button. And now we're going to have our timer counting down and the ball's falling from the ceiling. Much nicer. Starting to feel like a real game here. Oop, one more. Yes. Score of 7. Awesome. So let's go ahead. One of the things I'm noticing is that when we play the game, let's go ahead. It's only take us 10 more seconds to go ahead and play this game one more time. When the game is over, we've got this really nice start button, but we're now still using the default restart button. Come on, restart. We've got our own type style, so it looks okay. But we can improve that as well if we want to. And it's nice to know that we've got everything handled with our text. But let's go ahead and update that to match our start button. So first off, let's just clear out temporarily our splash screen and our start screen, selection editing, so I can select both of them and turn them both off at the same time. So they're now inactive. And let's bring up that restart button. And there again is the default GUI sprite and then a label. So let's go ahead and grab our restart button here. There's our restart button. So let's update the graphic with restart. Boom. And again, set native size. And we don't need the label anymore. Let's go ahead and fix that alpha channel. So now we have a restart button. Our on-click still works, just as it did before, set up the same way as we just saw with a restart game object and then our restart function. And while we're here, let's also have a quick look at this game over text. It's a bit small now that we've put that big button in there. So let's go ahead and just grab that font size. Just make it bigger. How big do we want it? Woohoo! Huge! Medium! Normal! 99. Let's make that 100. Me and my round numbers. Speaking of 100, let's push this up. I bet about 100 would be good. 100, 150? Let's go for 100. So now, much more bold in the game over. So it sort of matches the fact that our game is over and looks better with that restart button now that we have a graphic for our restart button. The last thing I want to do in this sort of cleanup, and we'll have to put these guys back to sleep, so let's grab those game over and restart buttons. Let's take the splash screen and the start button and bring them back. The big thing I want to do now, the last of the sort of cleanup and make things look like a real game, is stop this hat from moving. I don't want it to move until I hit the start button. So we need to edit the hat controller. And this gets a bit tricky because the hat controller is on a different script. So on our hat, we have our hat controller script. And it needs to communicate with the game controller script. So starting off just internally, what do we need? We need something that tells us whether or not we can control the hat. So let's start off with a private bool, a little bit like that is playing. Let's just call it can control. Can we control the hat? And then in start, same thing. We want to have can control equal to false. How about just one equal there? Equal to false. And then we do our work here in fixed update. So again, with the command, at least on, or I believe it's control on Windows, and then the right square bracket key, we indent all of that. And then we surround it with our if. We'll learn to spell if can control. So if we can control our hat, then it goes ahead and processes all of that hat code. But how are we going to turn it on? It starts off, and at some point, our game controller needs to turn this on. So let's write a public function, just like we did in the other script. Let's write public void toggle control. Sounds good. And it's going to take in a Boolean value. And this is slightly more complicated than we need to do here. We could just simply say set can control to being true, but I want to be able to be a little bit more clever here. We send it a Boolean. And then inside the code, what we can do is we can set our can control to be equal to the Boolean toggle that we send it. And the reason for this is it's a slightly more versatile because in this case we're only ever going to be turning it on. But it's nice to look at this as a sort of pattern where you can have a function that can set a Boolean to whatever you choose to set it to. So in this case, if for some reason, maybe towards the end of the game, when the game is over, you want to be able to turn control off, you can use this same function and send it a false toggle rather than a true toggle, and you can turn it back off again. We won't be doing that in this game, but hey, I thought it would be good for you guys to take a look at it. Now, in our game controller, we need to be able to set this and set it when we want it to. So let's go back to our game controller. And in our game controller, we want to have a public reference. And it's going to be of type hat controller, because that's the hat controller script. That's the type set by the name of the script that we have. And then let's just call this, give it a name, hat controller, with the lowercase h. Types, capital H, our variable name here is a lowercase h, hat controller. So we now have a reference to the hat controller. And in our start game, when we want to have the game start, here, our hat controller, and let's send to the toggle control, true. Does this make sense? So what we've done is on the hat controller, we've created that Boolean. We've made sure that it's off at the beginning of the game. And then we have a function that will turn it on when we set its toggle, when we send it a value. And then in our game controller, we give it a reference. And then we go ahead and send, when we're ready to start our game, we say to that hat control, toggle control, true, that we can control our hat. So let's save this. And let's return to Unity. What bliss. The console's clean. I always get that frightened moment, you know, you wonder what you've written wrong. So now we go ahead and we hit play, and we're going to run into big trouble if I don't populate my reference. So let's pretend I didn't hit the play button. Game controller. We now have to populate it. So there's our hat controller. And so all we have to do is drag the hat into the game controller. So we now have a reference to our hat. Again, save and play. And then we can see that the game is running, but we're not playing the game yet. We can see when we hover over the button, it changes color. Hat's not moving. Hit the start button, and now the hat moves. So we've contained that hat. So it looks a little bit more slick and a little bit more polished, that you know, nothing happens until we start our game with that start button. There's a nice big game over. And our restart button. Much more, it's weighted much more comfortably now, I think. So I'm going to leave play mode. So now let's make a bomb that will be mixed in with the bowling balls that fall from the top of the screen. So the first thing we're going to do is create our game object. Let's look at our sprites, and let's grab our bomb sprite, and let's just stick that in the scene. Let's go ahead and go to game view, and then double click or F for frame selected. We don't see our bomb yet because of the layers in 2D. Don't forget that you know, in our 2D game, everything is there on the Z-axis of 0, there at the center of the game world, and we are sorting all of our sprites because of the sorting layers and ordering layer that we are using in the game. So for our bomb, we want it to be on the foreground layer. The background is where we have the grass and the sky. The foreground is where we have the hat and the balls. So let's bring that forward, and then also let's give it an ordering layer of 1, and there it is in the middle of our hat. That's the same ordering layer that we have for our bowling ball prefab. I lied, we have 2. Let's put that into, let's double check. Hat's at 1. Sorry, I thought hat was at 0, and the bowling ball was at 1. So let's definitely make, and then we've got the front at 3. So we're using our order and layer because they're all in the same layer. So the first thing we sort by is the sorting layer, and the second one is by order and layer. So the hat and the balls and the bomb are now all on the foreground layer. And then our order and layer for the back of the hat is 1. For the bowling ball is 2. So we also want our bomb to be 2. And then our hat's foreground will be 3. So let's go ahead and grab that bomb. Let's move it up just a little bit so we can see it a little better. So looks nice. So let's prep this game object so that we can use it in the game. First thing that we're going to need is we want it to fall down under the influence of gravity. So we want to use physics 2D and add to it a circle collider 2D. Now I'm going to turn off the sky just for a minute because the sky is a bit bright when it comes to that collider, and we can see the green lines there. Let me turn off the ground as well, just because it's a bit distracting. So there's the green line of the collider. It's automatically sized to the size of the sprite's outline, which is bigger than we need, partly to keep the sprite centered and give us room for the fuse. So let's go ahead and grab that radius of that circle collider and just shrink it down till it comes in somewhere close to the edge of our sprite. 0.6, 0.61, let's make that just 0.6. So now we've given our collision volume, our collision area in this case, since it's 2D. So there's our collision area. It's a circle based around the center point at this point, because the center is at 0, 0. And you can offset these. So you can put these anywhere you want to on your game object. But we want ours centered on the bomb and around about the same size as the bomb itself. So now we have, oops, that's the circle collider. Oh, where's my rigid body? Was I not paying attention? Physics 2D, rigid body 2D. I think I just got ahead of myself. So we've got a rigid body 2D, and I jumped straight onto the circle collider without paying attention. So we've done both. We just need that rigid body 2D there for our physics, to work, so it falls down under the influence of gravity. And then we want our circle collider to give us our collision area. So that's just the basic setup. We've created our bomb. It will now fall under the influence of gravity, and it will bump into things. But let's go ahead and pimp it out. Let's test this first. Let's put the ground back in. There. Boom. Let's put the sky back in. Boom. And grab our bomb just to prove it. Play. Bonk. Oh, let's turn off our splash screen. I might be automatically turning this on. Try that again. Bonk. There we go. So we can see that's now colliding. But it's a bit boring. Let's go ahead and make it slightly more interesting. And what I want to do is I want to add some particle systems. I want some sparks to come from that fuse. And to do this, I want to import some additional assets. So we've seen how we can drag assets off of our desktop where we have material that we want. But also we can bring in packages from what's called a Unity package. And this is where you can store material from one project to another. You can create prefabs, or you can create textures and materials in one project, save them in a Unity package, and you can give them to other people. You can use them in different projects. So I've created one which has some particles and sprites that we want to bring into this project. So I'm going to go to my assets, and I'm going to import a package, custom package, so I can navigate to it, and I'll find it on my desktop, and there is my particle assets package. So let's go ahead and open that up. And we can see inside this package is a material called explosion particle. I've got an explosion prefab, a glow prefab, sparks, and a simple script called set particle sorting layers, which I'll talk about in a minute, and then an explosion graphic. And you can see by clicking on it, you get a little preview over here. So let's go ahead and import these. And we'll notice that it's going to file them away. Our prefabs are going to go in the prefabs folders. Script's going to go in the scripts folders if they match. If there isn't a folder for it, Unity will create one. So let's go ahead and import that in. And we can see we now have a materials folder, and that we have prefabs have been added, and our script down here has been added as well. So let's go ahead and drag some of these in. I'm going to turn off the sky again, just so we can see what's going on. Turn off our sky and turn off our ground. And then let's go ahead and bring in sparks. Woo, sparks. And let's sort of drag those around so they're there on top of our bomb. And then let's go ahead and grab our glow. Boop. And that's just a little glow bit that goes on top. Same thing. So they're in the right place. But if I move my bomb, oh, they're not in the right place anymore. I need to make these children, because remember that the transforms of children are always relative to their immediate parent. So if I grab these and make these children of my bomb, then grab the parent bomb, then the sparks and the glow will move with it. So when we're dealing with 2D, let's bring our grass and our sky back for a second and have a quick peek as to what we're going to have as a problem. So let's take a look again at our glow. Whoops. And our sparks, we don't see them. Where are they? Well, we can see them falling down here, and that's because they are on a different layer. And currently, our particle renderer doesn't allow us to use sorting layers. It isn't exposed that we can use sorting layers in order and layer. So we need to do that with a script. So we've got set particle sorting layer here. So I'm going to open that up in MonoDevelop and just have a quick look at this script. This is very important. You can see that we have a string, which is the sorting layer name, and an int, which is our sorting order. So we can set these just the same way that we were setting them on our sprites, but we can set them using code, in this code here. And we can say there's the particle system, its renderer has a sorting layer, and we set it to sorting name, and the sorting order is set to the int number that we are giving it. So even you can set any renderer in Unity to a sorting layer. It's just only exposed to do it in the inspector currently on sprites. So this prefab has the sorting layer name set to a layer called sparks, and we don't have one. So we need to go to our layers. Let's just, the easiest is to do it this way. Go to sorting layer and add sorting layers. There we go. And then let's create a new one called sparks. So we now have a sparks sorting layer. And then also, let's go ahead and figure out what the order we want them in. We want our glow to be on top and the sparks below. And so sparks are at 1 and glow is 2. Good. So when we have these on and the game is playing, we will see them. So if we go and we hit play, we can see that those sparks there are now on the top layer. Let's go ahead and test this actually. And rather than just taking a look at it, we need to grab that bomb. Let's move it over. Let's hit play. Well, not very impressive. We want it to explode. So we now need to write a script for when this bomb comes in contact with our hat. So let's grab our bomb. Let's add a new component. Let's add a new script. And let's make it explode. Ooh, lowercase, please. Explode. I'm not allowed to put exclamation marks in the titles of scripts in C#, unfortunately. And remember that this will dump our script here in the root, so let's go ahead and file that away in scripts, and then go ahead and open that up for editing. Now this is going to be a relatively simple script. It's going to do one thing, which is going to look for a collision, and then it's going to spawn an explosion. So let's get rid of our sample script here. And then let me just pump in here. Oops, wrong one. So you can see it a little better. So the thing that we need to have is we need to spawn an explosion. And so the first thing we're going to need is a public game object reference to our explosion. EXPLOSION. Explosion! Again, I can't put an exclamation point there. So that's a public reference to our game object explosion, which is going to be a prefab. But we also, and you'll see why we want this in a second, want to have a public array or list of particle systems. Public particle system. Thank you. And by making the square brackets after that, this is going to make it an array. And we're going to call this effects. And we want to have the collision trigger this new behavior. So we're going to write a new function called on collision, not on trigger, on collision, enter 2D. And if we don't put 2D down, we're going to be trying to activate the 3D version of this, and it won't work with the 2D physics engine. So we want to make sure we have on collision enter 2D. And we want to get the collision information, so we also want to ask for collision 2D. And we will call that, give it the name, something clever like collision. So if our collision, from the collision 2D information, if that collision has a game object, and that game object has the tag that is the same as hat, which we'll have to set up, then if we have that, we want to instantiate our explosion. Where do we want to instantiate it? At this location. So that's our transform with lowercase t, please. Transform position, and with our transform lowercase t, please. Rotation. There we go. So now what we've done is we've got the explosion and the effects. Why? We've got the explosion because we know we need to instantiate it. Why do we want those effects? Well, when we instantiate this explosion, we also want to destroy the game object that holds it. So if the collision is the same as hat, we instantiate a explosion, and then we destroy the game object. The problem I have with this is that also it'll immediately destroy the particle emitters. And it won't look as much fun. So let's go through each one of our particle emitters and say for each effect. And I'm going to say var. We need the type, but we can get that using var effect in effects. So for each effect that is in that array of effects, we want to have the effect have its transform parent equal null. Because remember that these objects are will be child objects of our bomb, but we want to blow the bomb up and it will take all of its children with it. So we divorce them. We basically say the effects transform, the parent is null, so it basically becomes parented at the world, on the world level. We want it to stop emitting, but we want those things like those sparks that we're spewing out, we want them to continue on their normal life cycle. So we're going to stop the emission, but we're not going to kill the particles. And then we are going to destroy the effect, but we're not going to do it immediately. We're going to destroy that effect, or actually the effect.game object. We want to destroy the game object holding the particle system in 1 second. So what we've done is that if the bomb hits an object and that object is a hat, we instantiate an explosion, we divorce all of the particle effects from them, ask them to stop emitting, and then destroy them with an invoke, destroy them after a second, and then we destroy ourselves, which is the bomb. And I've made a mistake. Where have I done do it wrong? Oh, how about a final semicolon? Go ahead and save that. Come back to Unity. Oh, and I probably have a typo as well. Collision. There we go. Collider 2D. Collision. Me and my... This should be Collision 2D. 2D, not Collider 2D, sorry. Probably me not paying attention to my code completion. I knew I would have one flurry of stupid errors while I did that. There we go. Clean, no typos, and the appropriate functions. The appropriate types. So now, if we take a look at our bomb, we have our explosion script, so we need to go ahead and populate this. So the explosion, just so you know, is a prefab that we have here again with a set particle layer. And this just simply makes an explosion. So let's go ahead and populate that with explosion, or our explosion. And then we need to populate the two children here as our effects. And I could drag them, I could create a size of 2 and then put them into the size itself. Not 20, please, 2. and then populate the slots. But Unity is really nice about doing things easily. I can just go ahead and drag them onto the title here, effects, and it will pop them in automatically. So that's glow and that's sparks. So our hat needs to be tagged. And there is no tag for hat right now, so we have to create a new tag, so we add tag. So we go to add tag, and we add the tag of hat. Save this, and then come back to hat, and we can see that hat is still untagged. Hat will be untagged unless we tag it again. The first add tag takes us to the tags and layers window, and we can go ahead and create a new tag called hat, but we still have to remember to come back and assign it. So now we can do that, save that, and boom, there we go. And we can see the thing that I like about that is those particles still exist, the particle emitters still exist, and we can see that spray of stars as it continues on. It's missing a bang. I want to have that explosion is too quiet. So there's audio here. I've got an audio clip called explosion.wav. So let's go ahead and drag that into our project. And we now have an audio file. And again, that's as simple as just dragging and dropping onto the bomb. Boom. And this will go ahead and set up our audio source and our audio clip and automatically give us play on awake. So what we're getting automatically with this is the sound will go off, and it will be destroyed when we destroy our bomb. So let's save this. So now we've got our bomb set up. Everything is working fine except our explosion clone isn't killing itself. We're left with these explosion clones behind. So let's go ahead and create another simple script. Create a C# script, and we're going to call this thing called self-destruct. How about self-destruct? Self-destruct. Self-destruct script, again, is going to be very simple. Double-click that to edit it. And remove everything but start. And we're going to create a quick public float called lifetime. And then self-destruct is going to simply call destroy in start, and it's going to destroy the game object it's attached to. But remember, destroy not only destroys the game object in that same frame, but you can give it a delay, and we're going to use lifetime for that. So now we've got a nice little self-contained reusable script that we can put on any game object that will destroy itself in the amount of time we give it as lifetime in seconds after it's been instantiated in the game. So we can grab self-destruct, and look, I'm dragging it directly to the prefab of the explosion. Come to the prefab of the explosion, and there's self-destruct. Let's have it 2 seconds. Explosion's probably less than a second, so I mean 1 second would be fine, but 2 safe. Now when we hit play, we lose the explosion clone. There's our explosion clone there. There's our glow and sparks. Step through in a couple of frames. This glow and sparks go away because they've been invoked with the destruction, and then explosion clone should go away. Take that off. Boom, there it goes. Lastly, let's go ahead and spawn these bombs. To spawn the bombs, we're going to need a prefab in our prefabs folder to feed to our game controller. So let's go ahead and make this bomb into a prefab. Boop. And we have a prefab of the bomb. And then let's remove the instance. So there's our bomb prefab. I'm going to go ahead and just reset this for cleanliness, reset that position. It's going to be irrelevant because the position will be set when we spawn it, but it makes me happy to know that that transform is clean. So there only needs to be one minor change to our game controller to be able to spawn these bombs. So let's go ahead and take a look at the game controller again. And if we look at the game controller, currently, let me just back out of these a little bit. We have one ball as a game object. So we're spawning ball. We are grabbing our ball width from that ball by looking at its renderer and finding its bounds and finding the extents of the bounds along the x-axis. And then we are spawning our ball. Now we want to spawn either a ball or a bomb. So we need something more complex. We need a collection of objects to drop. So let's change public game object into an array. And let's give it a plural name, balls. Just because it's going to make it slightly easier. And so now that balls is an array, we're going to need to take the ball width from balls 0. So we're going to take it from the very first object that we have in our list of balls that we drop. The supposition here, we could get more clever, but partly I want to keep this code quick and get the class through. But the supposition here is you'll always have at least one ball or your game's not going to work. So we'll get the width off of the very first ball we have. And then lastly down here, when we're spawning, while true, we create a spawn position and a spawn rotation. But remember, our instantiate needs an object, position, and rotation. So let's set the object and say our game object called ball, because we've no longer using ball. Remember, we changed our name to balls, equals. We're going to grab one at random, our balls, and we're going to grab one from that, oops, square brackets, please, one from that list. But which number? How many are there going to be? We don't know. And we want them to be random. So we want a random range from 0, the first one, up to balls.length, which is how many of these do we have? So we're going to get one at random. So our ball, which we're going to still instantiate down here, same name, balls.length. So we want a random one from slot 0 up to however many we have in the total list in the array. I think that's it. So let's save this. Now when we look at our game controller, if this all works, we now again have that array, size of 0, so there's nothing there. So let's grab a bowling ball, and then let's grab a bomb. And at this ratio between bowling balls and bombs, it'll pick one of these two at random. So every other one at random will be a bowling ball or a bomb. Simply because of the way that we've designed it, if we want to have more bowling balls than bombs, and make bombs to be less common, add more bowling balls. So it's going to pick randomly from the 3 of them, so we're going to have 2/3 chance of getting a bowling ball and a 1/3 chance of getting a bomb. And lastly, let's do one other thing, which is look at our score, which is on the hat. And let's edit our score script. And if we look at our hat, we have our edge collider marked for collision, and then we have another edge collider marked as is trigger. And if we look at our score script, is that when the trigger is activated, then we count up a score. But when the bombs smash into the collider on the outside and they explode, that's a proper collision. And that's where we want to lose our points. So if we come down here and we say void on collision, enter 2D. But we don't want our bowling balls to trigger this. So if, oh, and the other thing is we want collision. We want, again, our collision 2D. And I can actually try to spell it this time. Collision 2D rather than collider 2D. Collision. So if our, again, our collision game object tag is the same as bomb. So if the thing that hits our collider, not the one marked as a trigger, but the one that is a proper collider, is marked as bomb, then we take our score and we minus equal, we decrement it by the ball value times 2. So we'll get 1 point at this point because we've assigned a ball value of 1 for when we catch a ball on the trigger, but we'll lose 2 points if a bomb hits anywhere on the collider around the hat. Now, technically, if we can align our hat just right and catch the bomb on the trigger, we'll get 1 point back. Just because of the way we set it up, because it is possible that that bomb will land inside, and it's even more possible that if it never touches the sides and you catch it perfectly on that trigger without hitting the collider, you'll get 1 point without losing 2. Hey, we can stay up all night trying to do that. So technically, this should work. Let's see. Cut back to Unity. Watch the little spinny. We've compiled with no errors. Fantastic. Let's turn our start button and splash screen back on. Let's take our bomb prefab and let's tag that. We have to remember to add a tag, and that tag is going to be bomb with a capital B, case sensitive here, remember. And then back to our bomb again to tag that as bomb. Save this. Let's hit play. Start. Ooh, bomb, bowling ball, bomb. Oh, lost 2 points. So, oh, what am I doing wrong? That gets going up. That's right. Okay, let's try that again. I didn't pay 100% attention. Let's make sure that that is working correctly. Silly errors. Boo, not going down. Something is not correct. All right, let me just double check. Our bomb is bomb. Bowling ball is untagged. Our score script says if... Oh, I haven't updated score. That's my problem. Sorry about that. We don't update the score. We have to remember to update our score text, which we remember from the earlier episode. Update score will then take our score text.text and make it equal to the text string score and a new line plus the new score that we've set. So internally, we were updating our private int score, but until I added the update score, we weren't adding that to the display. So sorry about that. Now, I was thinking our logic was mostly correct. So let's go ahead and play this game again. Bowling ball, bomb, -1. That's -3. Excellent. So that's acting as that we want it to be. So we now have our game. Restart. Start button. -2. Oh, I'm going to avoid you today. Oh. Whoa! Well, there's the law of averages there for you. 0. Another 0 score. Anyway, so that's the game. We're going to package this up along with some other 2D things and get it up on the asset store. Going to go into Q&A in just a moment, but before we do that, I want to say follow us. If you have any questions, go ahead and follow us on Twitter at Unity3D, at Mike Geig, at Will Goldstone, and me, Adam Buckner, at The Ant Ranch. And we're perfectly happy to answer tweets. You can post on the teaching section in the forum if you go to the forum. Brand new forums this week, guys. Go take a look. You'll see in the stickies that there is a thread on live training. If you have any questions, comments, criticisms, requests, go ahead and post them there. Or you can also do that here with us on Twitter.